In this video, I will demonstrate how to perform K-means clustering using Analytic Solver. We're using the same data file, which contains 30 applicants, their age, gender, income, marriage status, number of children, loan, and mortgage. Under the data mining, under cluster, select K-means clustering. In the K-means clustering window, we can see that data sheet is showing. Make sure that the first row contains headers is checked and all the variables displayed in the left pane. We're going to select 3 variables: age, income, and number of children. Notice that all 3 variables are numerical variables and they contain different numeric values at different scale, which means in the next step, we're going to choose normalize input data. Normalize input data standardize the values of the input variables by calculating their z-scores. In the number of clusters, we choose 3 for now. Later, I will explain how to find the best number of clusters. For the number of iterations, choose 10. So the number of iterations correspond to the number of times the cluster centroids are recalculated and observation reassigned to the clusters. We also want to choose the random starts to be 10. So because my Mac version of the Analytic Solver doesn't show the up or down arrow, I need to highlight the value in the box and use my up arrow on the keyboard to increase it to the desired value of 10. We also want to set the seed, so we can enter 1, 2, 3, 4, 5 as the seed for centroid initialization, so we can reproduce the clustering experiment. That means every time we perform the clustering results should stay the same. Next, we want to make sure show data summary and show distances from each cluster center are selected. And then when finished, this will output 2 new worksheets: KMC output and KMC clusters. KMC stands for K-means clustering. So in the KMC output, we first see the summary of the K-means process, including the data file selected and the variable selected and the settings. We also see the 10 random start summary. More importantly, we see that cluster centers showing the cluster centroids in normalized units of the input variables, that is age, income, and children. This helps us to understand what each cluster means. So cluster 1 contains youngest 15 customers with the lowest income and the largest families. In contrast, cluster 2 contains the oldest customers with the highest income and an average number of children. And cluster 3 contains older than average customers with moderate income and with a few children. The intercluster distance shows the distance between 3 cluster centers. We can see that cluster 1 and cluster 2 are most distinct pair of clusters because they have a largest distance of 3.072. Cluster 2 and cluster 3 are the second most distinct pair of clusters with a distance of 2.059. And finally, cluster 1 and cluster 3 are the least distinct clusters pair with the smallest distance of 1.854. Next, the cluster summary shows the within cluster distance. We can see that cluster 3 is the most homogeneous because it has the lowest average within cluster distance, versus cluster 1 is the most heterogeneous because it has the highest average within cluster distance of 1.24. Next, in the KMC clusters, this shows a table of each observation is assigned to which cluster. We can use this table to evaluate how well an individual observation fits its assigned cluster relative to others. For example, record number 9 is assigned to cluster 1, and it shows that it has a closest distance to cluster 1. Versus it has a much larger distance to cluster 2 and 3. We can also copy the data from the original data set and add it to this table and then generate a pivot table just like what we did with the hierarchical clustering. So we're going to select the variables that we chose for the k-means, and we're gonna change the sum to average. And then we can see that the result is the same as the KMC output tells us. We can change the format to make it easier to compare. So we can see that cluster 1 still contains 15 observations with low age, low income, and higher value of children. Next, as I mentioned, I will talk about the approaches to find the best number of clusters or the best K. With Python or other data mining software such as RapidMiner, they may easily output the results of within cluster sum of squares or WSS, or other indicators for finding the best case such as elbow chart, Davis-Bowden index, or silhouette chart. But for Analytic Solver, it doesn't output such results, so we have to manually calculate it. So there are two approaches to do this. The first approach is that we can use the minimum sum of within cluster distance. We're going to use the output from KMC clusters, this table, that it tells us each record their distance to the centroids of each cluster, especially their assigned cluster. So we're going to use that to calculate the WSS this way. For example, record 1 is assigned to cluster 1, record 2 as well, 4 as well, but 3 is assigned to cluster 3 and 5 is assigned to cluster 2, and so on. So then we can calculate the total WSS, and this is the case for k equal to 3. And we're going to run it from k equal to 2 to k equal to 10 and compare their WSS. Choose the k that outputs the minimum sum of within cluster distance. That is to choose the k with the lowest WSS. The second approach is that we can use the maximum average inter-cluster distance. So this is easier compared to the first approach because Analytic Solver provides directly the inter-cluster distance in the KMC output. So you can use this information directly. This is for k equal to 3. And then we run it from k equal to 2 to k equal to 10. We see that even though k equal to 5 have a higher value of average inter-cluster distance than k equal to 3, we still choose the 3 to be the best k because we can see that when k equal to 4, the average inter-cluster distance actually decreases. So this is when we say k equal to 3 is the elbow in the elbow chart. It's not worthwhile to add another cluster. At the end of the day, regardless of what techniques you use to find the best K, the most important is to finding valuable and meaningful clusters that can translate into actionable business insights.